Hi, everyone. My name is Liz Richardson, and I'm one of the technical program managers here at LAS. In this video, I'll be talking to you about the Operationalizing Artificial Intelligence and Machine Learning Research Area of Interest, which I might also refer to as OAIML. This is section 3.1 of our call for white papers. And if you haven't already, I encourage you to read the call for white papers in addition to watching the corresponding videos that we've released. My goal today is to discuss this section of the call and elaborate on some of the challenges that we hope to address in 2025. There will also be a live Q&A session on May 30th, 2024, where my colleagues and I will be available to answer your questions. Please reach out to las-whitepapers@ncsu.edu if you have any questions, or see the call for white papers and our website for information on how to attend the Q&A session. I will also reiterate this information at the end, so I will continue on. In the OA-IML research area, we investigate how we can actually use AI and ML to help our customers in their analysis work. And this is something we've been doing since LAS was created, and that continually evolves along with technology. It seems like every day new advances in artificial intelligence and machine learning are announced. So there is a lot to understand about how they work, how these new capabilities compare to or complement existing AI and ML tools, and to see what possibilities might exist now that weren't an option with previous technology. Also, how do we get these capabilities into operations? We can't exactly say, hey, everyone, just go use ChatGPT for everything. Sure, it's powerful and appropriate in some cases, but we don't have any control over how that type of system works or when it's updated or what data goes into them. Nor can we also just replicate those capabilities in our own environments. They require enormous amounts of computational resources, training data, and engineering expertise, which few organizations actually have. Plus, they are simply not the right tools for all tasks. So when we think about how to incorporate AI and ML into operational workflows for intelligence analysis, there is a lot to consider. Today, I'm going to talk about some of the open research areas that we're interested in the OAIML space and that we want to investigate in 2025. Starting with generalized knowledge distillation pipelines. There's an LAS project called iReckon that focuses on creating video processing pipelines. And one challenge that they've run into is that video models get really, really large, and hosting those models is expensive. And it's not always practical to rely on being able to use those large models, especially in situations where bandwidth or compute power might be really limited and there's a lot of competition for resources. This problem is certainly not unique to that iReckon project. Some of the large language models that are available today have billions of parameters and a large footprint, and it's just not feasible for all projects or organizations to manage them. So while the general trend tends to be building larger and larger models to outperform smaller models, it's not always possible or practical to use those large models for everything. There are approaches to distill these large models to create smaller, more focused models. And at LAS, we've had some success distilling those large video models into smaller, faster models that are easier to deploy. And those small models are more accurate than similar models that we could create following traditional model development processes of labeling data, training a model, evaluating performance, adding more data, etc. But as well as those smaller distilled models work in some cases, there are other cases when they fail. In the video object detection space, it might be that models can identify certain types of objects well and struggle to identify another type of object. Like maybe a model can reliably recognize a bicycle, but doesn't recognize scooters or labels them as something else. Or perhaps the smaller model identifies an object well in certain conditions, then that same model fails to identify that object in other conditions. Additionally, most knowledge distillation techniques, including the ones we've used at LAS, are only applicable in certain conditions. They typically only apply to one type of model, such as a vision or text model. And it might be necessary to have some labeled data available to fine-tune the distilled models. So these distillation techniques might not be relevant or applicable in all cases and might also require some non-trivial effort to apply. So we're interested in learning more about knowledge distillation pipelines. For example, is it possible to understand why and predict when distilled models will succeed or fail? Additionally, can we develop a technique or create a knowledge distillation pipeline that works for multiple types of models? Could we plug in different types of large models without having to reconfigure the entire pipeline? Proposals for projects that would answer those questions and demonstrate those capabilities are welcome. Looking at models tailored to individual user needs, in talking to analysts, you'll learn that they are often asked to try out new models that are intended to help them in some capacity, and most are happy to try them out with some caveats. The models have to work for that user, at least somewhat decently, or if the models don't perform that well, the path to improving those models can't require a ton of work on the analyst's part. So the possibility exists to incorporate analysts into the model improvement and customization process. There are many ways to tailor those models, and those methods are largely dependent on the model that's being used in the context in which the model is being applied. For instance, it might be appropriate to fine-tune a model to better perform for a user, or maybe the situation could take advantage of various prompt engineering approaches to influence model output. But to tailor models, it will be necessary for users to somehow provide feedback that can inform the model how to perform better for that user. And that feedback mechanism shouldn't be annoying to users, because if we ask users for extensive descriptions of why each model output was or was not relevant, useful, correct, no one's going to want to use that system. But there does need to be some way for the users to indicate that the model output was relevant, maybe that it was wrong, or maybe in some cases that the model is producing too much of one type of output. So I'll use the tailored daily summaries application area as an example to talk about some of the ways that context might be application specific. If we're building a system to generate daily summaries of data from various sources, we might assume that there's a recommender model identifying relevant reports to present to the user. One common way to collect user feedback is to assume that if a user clicked on a report, then that report was relevant to that user. But what if a user doesn't click on a report? Is it because that report wasn't relevant, or is it because the model already recommended so many other reports very similar to that one that it's created an information bubble and the model's no longer productive or helpful? How can we get that kind of feedback from users? Feedback that requires more effort on the user's part, but that would be really helpful for the model. That daily summary system would probably also have a summarization model to generate those daily summaries. And we don't want to ask analysts to read every source report and write their own summary. So what kind of feedback could those users provide, and how to influence the summarization model? Could this feedback mechanism adapt over time? For example, maybe it is reasonable to assume that when we first deploy this system, a user would be hesitant to just trust its output and would actually read every report and write their own summary. So could we initially have users generate that very thorough kind of feedback and provide that back to the summarization model, and have the system adapt over time so that the user can provide less and less feedback as it gets more tailored to that user's needs? How do we know when to stop tailoring that model? So we're looking for projects that can demonstrate productive, efficient ways to tailor models for any of those application areas. I just covered one interpretation of one application area. Perhaps in another interpretation of the tailored daily summaries application area, those summaries could be presented in a chat-based interface, which might invite an entirely different set of questions. And I will note that there is a chat-based triage focus area in the content triage portion of the call for white papers. So I recommend looking at that for more discussion about chat-based interactions. Now to dive a little bit deeper into automated summaries, looking at traceability in automated summaries. So I just talked a bit about generating summaries of reports, but in reality, of reports, but in reality, analysts interact with all types of data through the course of their work. And that may be in different formats, different modalities, possibly different languages, have different refresh rates, exist in varying amounts, etc. And analysts sift through that information, comprehend it, synthesize it, and then convey their understanding somehow, such as through intelligence products. And in those intelligence products, analysts need to be able to support their analysis, their findings and hypotheses, and refer to the information on which they base their analyses. They need to be able to trace the connections between information they consumed and the output they produced. So if a model is going to automatically generate summaries of source content, then the model should also include those references back to the source content. If the information in an automatically generated summary can't be traced back to the source, then that summary is just not useful for an analyst. There are automatic summarization capabilities that exist today. We could use extractive summarization approaches to take passages directly from the source, then collate them into a condensed version to make a summary. And this approach makes it pretty straightforward to refer back to the exact location in the source where information originated. And it works pretty well for test data, but is not fail-proof. It's possible to extract passages that wind up creating an awkward or maybe a misleading summary. And then the extractive summarization approach doesn't really work very well for audio and video data. You're creating a shorter audio or video file that just might not make any sense the way it's put together. Or maybe an analyst just wants to read a text-based summary of that data. LLMs and generative models can create abstractive summaries that paraphrase source content. And some of those models can also summarize multimodal information pretty well. One well-known challenge, though, with these approaches is that they hallucinate or introduce false information into a summary. There are some approaches to identifying and mitigating hallucinations. For example, you might just ask the model to provide citations, but sometimes those citations themselves are hallucinated, or maybe the citation exists, but really doesn't relate to anything that's presented in the summary. So while the new multimodal capabilities, some new models are very impressive, there's still a lot to learn on how to elicit correct, comprehensive output from them that reflects the type of details an analyst would include. If we look to the application areas for more context again, what happens when we try to automatically summarize technical information? If we pass some CAD drawings, diagrams from patent applications, maybe some sensor data or academic papers to a model, could the model summarize that data? How well? Does the summary refer back to the specific portions of the source data so that a reader could drill down into the underlying source? So we're interested in understanding more about how to create automated, traceable, multimodal summaries, what works, what doesn't, why or why not, and we're looking for projects that can answer these questions and demonstrate these capabilities. Moving on to assisted development of analytic workflows. At LAS, you might hear that if you've talked to one analyst, you've talked to one analyst. And this means that all analysts have different focus areas, skill sets, responsibilities, which is true, but analysts also all adhere to best practices for creating rigorous products. But it takes time and repetition to learn how to employ those best practices, and there can be challenges presented by the analytic context itself. For example, an analyst might be the only person focusing on a specific area, or maybe the situation they're following is evolving rapidly. So for junior analysts who are just learning how to apply those analytic best practices to their own analysis workflows, it's often helpful to pair them with a more senior analyst who could help guide them through the process. This isn't always feasible, of course, which is where LLMs come in. LLMs have demonstrated capabilities in reasoning and planning tasks. There's documentation of these analytic best practices. So could we combine LLMs with that documentation of best practices to emulate that kind of mentor-mentee collaboration? Is there a way that we could provide LLMs with the existing knowledge of analytic best practices to complement the LLM's own abilities in planning and navigating complex analysis tasks? Could the LLM adjust to the dynamic nature of analysis and collaborate effectively in different scenarios? So we're interested in learning more about what opportunities exist for incorporating some kind of LLM-based assistant into an analyst workflow. There's a human-machine teaming aspect here, since analysts will need to trust the assistant, maybe be able to provide feedback. And I recommend that you have a look at the HMT portion of the call for white papers for additional areas of interest. So those are our 4 OAI ML focus areas. As a reminder, you can view the full call for white papers with all details regarding submission of proposals on our website, ncsu.las.org. No, ncsu-las.org. If you're interested in engaging further with us on operationalizing artificial intelligence and machine learning, I'd invite you to register for the Q&A session that will be hosted by our team on May 30th. A reminder that the deadline for submitting white papers is June 28th. And if you have any questions throughout this process, please reach out to us at las-whitepapers@ncsu.edu. Finally, thank you for your time and attention today. I encourage you to view the other videos we've posted to understand more about LES areas of interest and how to collaborate with us.